Description and properties of a field. A field is a region around an object where its force can be felt without physical contact. In physics, fields explain how objects influence one another at a distance. Example, the earth pulling objects downward. This is a diagram of a force that is acting on the earth that pulls objects downward. Another example is a magnet. Now, this is a magnet attracting iron filings. This is an example of a charged object attracting small pieces of paper. Description of a field. A field has the following features. A field is a region in space where a force can be experienced by an object without physical contact. And so these three objects here, these three pictures, we see different fields or forces acting around these objects, even without making physical contact with the objects. In the first picture, we see a force acting towards the center of the earth. In the second picture, we see a force attracting iron filings to the magnet. In the third picture, we see a charged object, a comb, attracting pieces of papers. So every field has the following features. Number one, a field occupies a region of space. Number two, a field exerts force at a distance. So objects within the field experience a force without touching the source. Number three, a field has direction. In the first diagram, we can see that the field is acting towards the center of the earth. So that is the direction of that field. That's the direction of the force. So it has direction. Every field has a definite direction at each point, shown by field lines. So when the field lines, the imaginary lines that describes a field is drawn, we use those lines to show the direction of the field. Number four, the strength of a field varies. So the field is usually strongest near the source, while it becomes weaker farther away. We talked about something like this in electric field yesterday, when we were talking about the strength of an electric field. We said the closer the electric lines, the closer the field lines, the closer the field lines, the stronger the electric field. The farther away the field lines are from each other, the weaker the electric field. So field strength varies. So you feel the field stronger when you go close to the object, and the strength of the field gets weaker when you move away from the object. So it can be represented by field lines. Fields can be represented with a field line. An imaginary line can be used to draw field or to represent a field. So field lines show the direction, and they also show the relative strength of the field. So closer lines indicate a stronger field. Rules of field lines. Field lines show the direction of force. Field lines, they never cross each other. Field lines are closer together where the field is stronger. Field lines are farther apart where the field is weaker. Depending on the type of field and the nature of the objects involved, fields can either attract or they can repel. Properties of field. Field acts without contact. So objects can experience force. They can experience field force without touching. Example, a magnet attracts a nail without touching it. The second property of field, fields have direction. We talked about this before, features of field. So gravitational field lines point toward the center of the earth. Electric field lines move away from the positive charge and toward negative charge. Magnetic field lines move from north pole to south pole outside the magnet. This shows that fields have direction. Fields decrease with distance. Field strength reduces as distance from the source increases. Example, a magnet attracts strongly when close, but weakly when far away. Fields can be attractive or repulsive. So let's look at field types and see whether the fields are attractive fields, whether they attract object or whether they repel object. A gravitational field attracts object. So that's why gravitational field act towards the center of the earth. Gravitational field do not repel object. They only attract. They only draw object towards the center. They act in one direction. An electric field is both attractive and repulsive. So electric field acts in two directions. It can attract object, it can also repel object. So when an unlike charge is brought near, when unlike charges are brought near each other, they attract each other. When like charges are brought near each other, they repel each other. Magnetic field is also both attractive and repulsive. Magnetic field also works in two directions. It attracts and then repel. Fields can be uniform or non-uniform. So uniform field, in a uniform field, the strength of the field is consistent. So field lines are parallel and equally spaced. An example, between two charged parallel plates. Now in this diagram, this is a uniform field. You can see that the field strength is uniform. The field lines is uniform. The distance between the lines is the same. This is the force field or the field existing between two charged parallel plates. A non-uniform field, field strength changes from point to point. Field lines are not evenly spaced. Example, field around a single charge is non-uniform. Effects of field. Fields can cause motion. Fields can change direction of motion. Field produces force. Field store energy. Example, a charged object in an electric field experiences a force. So if you put a charged object inside an electric field, it will experience two forces, either a repulsive force or an attractive force. So the properties of the fields are: 1, fields act without contact. Fields have direction. Fields decrease with distance. Fields can be attractive or repulsive. Fields occupy space. Fields can be uniform or non-uniform. Summary of fields. A field is an invisible region where force can be felt without contact. Key properties of field. A field has a source. A field has direction. A field has strength. A field acts at a distance. A field can be uniform or non-uniform. The strength of a field decreases with distance. After watching the video, here are a few questions that I want you to do. Question number 1, which type of force field acts on any object with mass? Which type of force field acts on any object with mass? What determines the direction of electric field lines around an isolated negative charge? State two difference between gravitational fields and magnetic fields. How does the distance between two masses affect the gravitational force between them? Calculate the electric field intensity if a force of 4 Newton acts on a 2C charge, on a 2-coulomb charge. Calculate the electric field intensity if a force of 4 Newton acts on a 2-coulomb charge. So the formula of electric field intensity is E is equal to N all over Q, where Q is the quantity of electric charge and N is the force, it is electric force.